Hello, this is Mr. Flatness, and today we'll be looking at unit rates, lesson 3.1. And our goal would be to determine how to solve unit rate problems using models and proportions. The first thing we're going to do is define two vocab terms. One is rate, and a rate would be a ratio of two quantities that have different units. If you recall back in the lessons about what a ratio was, a ratio combined two quantities that have the same units, where rates will have different units. So again, a rate is a comparison. A unit rate would be a rate that would have a denominator of 1. So basically we're comparing something to 1 unit. Please write these terms down and their definitions in your notebooks, that way you can have them memorized. In our first example, we have a rate problem, and we're going to use a model to show how to find the answer of the unit rate we're looking for. So, our problem is a vegetable garden grows 28 centimeters in 1 week. How many centimeters will grow in 1 day? So, again, the unit rate we want to talk about is with a denominator of 1. Okay, in this case, we're going from 1 week to 1 day. So what we need to do is understand obviously how many days there are in a week. So what I've done is I've taken a picture of 7 small rectangles, and those rectangles represent a day in a week. So if we can first model that we know the whole length of the diagram is going to represent the 28 centimeters that the plant grew. So that's what we're going to talk about there. Well, then all I need to do is split that 28 up into 7 equal pieces, and then that will give me how many centimeters grew in 1 day. So we're going to compare that as 28 divided by 7. And when we do that, we get 4. Each one of these would be 4 centimeters. And I can check that multiple ways, either through addition and add up all the 4s or multiply the 4s by 7. But in the end, you're still going to get 28. In our next problem, we have another unit rate question where Danny types 70 words per minute. How many words can she type in an hour? Again, I could use a model like what we did in the previous problem, but you can start to see how drawing models can be sometimes inconvenient. In this particular case, we would need to draw a model knowing how many minutes there are in an hour. Well, we know that there are 60 minutes in an hour. And so drawing a model for this would be somewhat inconvenient. So instead, we need to use a different method, which is an algorithm. So to do this, we're going to first take the 75 words per minute and write it as a ratio. So I'm going to take 75 words per 1 minute. And then what I can do is I can take that times a conversion rate. So we know that there are 60 minutes in 1 hour. So I'm going to put the 60 minutes diagonally from the 1 minute, and then I'm going to put down here hour, because in the end I want words on top, and then I want the words per, in this case instead of words per minute, I want the words per hour. So my words go on top, the time unit goes on the bottom. So we went from minutes, and now we're going to move to hours. So if you remember multiplying fractions and canceling, some nice things happen here. I can cancel the term minutes because they're diagonal from one another. And then I can just look at canceling numbers, in which case 1 and 60 I cannot cancel, and 1 and 75 I can't cancel. So in order to get my answer, I just need to take 75 times 60. And when you do that, you get 4,500. And then that would be words. And now it's going to be words per, and then now what's left at the bottom here is hour. So words per 1 hour, which is a unit rate. Our next example, we're to write 24 pages in 15 minutes as a unit rate. So again, knowing what unit rate means I need to have a denominator of 1. So what am I comparing? I'm comparing two things. I'm comparing pages. In this case, I'm talking about pages to a time unit of minutes. And right now I know that I can go 24 pages in 15 minutes. Oops, and I can erase that because I already have my label. So 24 pages in 15 minutes, and what I want to do is compare it to a unit rate of 1. I want the denominator to be 1. So this is going to be equal to some number over 1. So now to finish the problem, I'll need to work with this equivalent fraction. So again, I can look at whatever I do to the denominators, I'm going to do to the numerators. So to go from 15 to 1, I have to divide 15 divided by 15. So then I'm going to do the same thing to the top. Divide 24 by 15. And I can do that over here. 24 divided by 15. There's a few ways we can write this answer. So in dividing, I know that 15 goes into 24 once. And I can subtract. And then I can get 14, take away 5 would be 9. So I could write this as a mixed number, 1 and 9/15, which reduces to 1 and 3/5. So I could say that, but that doesn't, make as much sense maybe as a decimal. But I could say 1 and 3/5 pages per minute. We could also write this as a decimal, in which case 24 divided by 15 would be 1. And I get 9. So then I'm going to add a decimal and a decimal up top, and then add a 0 and bring it down. And 15 goes into 96 times, and I get 90 with 0 as a remainder. So I could also say 1.6 pages per minute. And either one is fine. To me, a decimal seems to make a little more sense than a mixed number. But basically, I can create and make 1.6 pages per minute, which is a unit rate. In our next example, we have a very popular rate that's used a lot in real life. And that would be a rate that is talking about speed. Speed is a rate of change. And how I measure it is I take my distance that I'm going and I divide it by my time, and that would give me my rate of speed. A lot of times you think in a car you're going to be going miles as your distance per hour as your time unit. But we can also talk about different examples, like the one we have where it takes you 1.5 hours to jog 12 miles. What is your average jogging speed? So again, we talk about speed as distance divided by time. So I'm going to write this as my distance, which is 12 miles. And I'm going to talk about miles versus time. And I can do that in 1.5 hours. And we want to know, what is my speed? Well, again, a speed is a rate where we want to compare it to 1. It's a unit rate. We want to compare it, not how many miles can I go in 1.5 hours. I want to know how many miles I can go in 1 hour. So we solve that just like the others. We can deal with it with making equivalent fractions. So 1.5 divided by 1 1/2 gives us 1. So I just need to take 12 and divide it by 1.5. And so we've done that with our fractions. 12 divided by 1 1/2 is the same thing as saying 12 divided by 3/2. And again, remembering how to divide fractions, we multiply by the reciprocal. So that's going to be 12 over 1 times 2/3. Now I can cancel. And so 3 and 12 I can cancel and get 1 and 4. And now I have, and 1 and 2 I cannot cancel, so I'm going to take top times top. 4 times 2 is 8. And 1 times 1 is 1. So basically what I'm saying is I can, if I jog 12 miles in 1.5 hours, I can jog 8 miles per 1 hour. So that would be my speed, 8 miles per hour. In the next example, you'll see that my labels or my rates change. Now I'm looking here at going, it takes me 1 minute and 40 seconds to walk 550 feet. So what is my average speed? Well, now if you notice our time, we have minutes and seconds, which is 2 different time units. We need to change that all into 1 time unit. And then here would be my distance. So we're going to be talking about feet, and we're either going to talk about feet per minute or feet per second. And I think when you're talking about walking, you're going to want to deal with feet per second. So the first thing we want to do is take 1 minute and 40 seconds and change that all into seconds. So we know that 1 minute is equal to 60 seconds. So I can take 60 seconds plus 40 seconds, and I know that that's 100 seconds. So that would be my time unit, 100 seconds. And I know that I can do 550 feet in that amount of time. So I'm going to start writing that as a ratio, 550 feet per 100 seconds. I'll put that over feet and seconds. And so because I want it to be a unit rate for an average speed, instead of 100 seconds, I need that denominator to be 1. How many feet can I go in 1 second? So simply all I need to do there is divide both numbers by 100. Because as you can see, if I want to go from 100 to 1, I need to divide that number by 100. And so I would need to do the same thing to 550. I need to divide that by 100. So in doing so, that's a pretty easy thing to do, because dividing by a power of 10, which is 100, I just need to move the decimal 2 places to the left, because there's 2 zeros in 100. So my answer is going to be 5.5. And that would be 5.5 feet per second. And that would be my answer for that one. So you can see unit rates are very helpful in determining how fast that I can go when we're talking about speed, whether it's miles per hour, feet per second, or feet per minute, miles per minute, however you want to do it. In our last examples, we're going to talk about how unit rates are used to compare. And we're going to use this 2 examples to talk about different bargains that you might see within supermarkets and knowing what product to buy based upon the unit rate. And that helps us determine what's the better buy. So in our first example, we're going to be looking at buying 10 pounds of pasta for $15, or do I want to buy 2 pounds of pasta for $3.98? So I'm going to set it up as a unit rate, and again, rates, we're going to compare 2 things. So we want to find what is the cost, in this case, per pound. So we can start out by saying, well, I know that I can take $15 is going to buy 10 pounds of pasta. So to find the unit rate, then I want to find out, well, how much does 1 pound of pasta cost? So I use my proportionality, and I can or equivalent fraction, so I'll take 10 and divide it by 10 to get 1. So whatever I do to the denominator, I do it to the numerator. And 15 divided by 10, again, slide the decimal 1 to the left, so that's going to be 1.5. When you think about money, it would be then add a 0 to it, so that'd be $1.50 per pound if I bought the 10-pound version. So $1.50 per pound. Now let's take a look at the next example, or the next option. I could pay $3.98, and I can buy 2 pounds. So again, I'll compare that to 1 pound. So that here I'm going to need to divide both the numerator and denominator by 2. And 398 divided by 2 is $1.99. So you can see if I buy 10 pounds, I only have to pay $1.50 per pound. But if I only buy 2 pounds, then I would have to pay as much as $1.99. So the better buy would be to go out and buy your 10 pounds of pasta. That would be your better buy. And normally that's usually the case. Buying in bulk is cheaper. So if you buy the 10-pound version, you're only paying $1.50 per pound. In our next example, we have buying batteries. And I can buy 2 AA batteries for $1.50, or I can look at buying 6 AA batteries for $4.80. So again, I would want to find out what would be the cost of one battery. So I'll set up my comparisons. Again, I want to find out what is the cost per battery. So those are the two things I'm comparing. So I can take $1.50, and that's going to get me 2 batteries. So I want to find out then, well, how much would be the cost of one battery. So I can divide both the denominator and the numerator by 2. And half of $1.50 would be 75 cents. So using that package or deal, I could pay 75 cents per battery. Over here, I got 6 batteries for $4.80. So I'll take $4.80 and compare that to 6 batteries. And then how much would that be at the current rate if I wanted to buy just one battery or per battery? So I'm going to divide both numerator and denominator by 6. And $4.80 divided by 6 is going to be 80 cents per battery. So in this case, it doesn't pay to buy in bulk. It actually pays to buy the smaller quantity, because here we're only going to pay 75 cents per battery. So I would want to buy the packs that come in 2 for about $1.50 and buy as many as I need, versus taking and buying the 6-pack for $4.80, because there I'm paying 80 cents per battery. So yeah, the 2-pack is a much better deal than the 6-pack. This concludes our lesson on unit rates. Please make sure you take good notes and replay the lesson as needed so that it can help you in your homework.